We're going to be talking about how to locate the embedded right triangle inside of a hyperbola. Hyperbola. Now, two characteristics that will help us in graphing our hyperbola is that they're just like the ellipse in that their foci live on the major axis, and they're just like the parabola in that the hyperbola always wraps around its focus. So in the major axis being horizontal, the picture on the left, we see that the vertices are located here and the foci are further out. So that's unusual. We usually see the foci in the ellipse being inside on the right side of the inner side of the foci, but this time they're on the outside. So you can see what's happening. We're going to pass through the vertex and we're going to wrap around the focus. So this is just a real quick example of what the hyperbola looks like. It always passes through its vertex, but it always wraps around its focus. In the other picture, we have the vertices located here and the foci further out. And again, we wrap around our focus, passing through the vertex on the top and on the bottom. Okay, so the pictures look like that, but let's talk about this embedded right triangle that will help us work with these things. First of all, the distance from the center, which I put at the origin, HK, at the center, the distance from that to the vertex, that is the distance which I call the horizontal distance. That is called A. Well, the horizontal distance on the vertical major axis goes from the origin out to the point on the side. That is also called A. Now, the vertical distance on the horizontal, the left side picture, goes from the center up to the top point. That is called the distance B. And it's the same thing here, but here it goes to the vertex. It goes to the vertex. From the center to the vertex, it's also called B. We don't have a distance labeled here to the center, from the center to the focus yet. Let's talk about that. The distance from the center to the focus, which is going to get pretty messy if I draw it in here, so I'm going to do it down below. So from the center, this distance from the center out to the focus, that is called the distance C. And over here, from the center out to the focus, that is called the distance C. Now let's draw our right triangle connecting on the first picture on the left. It's going to be connecting the vertex to this outer point on the vertical axis. So here's our right triangle. And we have the sides already labeled. We have A down below on the left-right distance from the center, going out to the vertex. And then up and down, it's the distance B. So what do you suppose the hypotenuse will be labeled? It's going to be the label of the distance C, the distance from the center to the focus. So we'll get a distance C here. And let's put it on our right triangle. Now, on the other picture, the picture on the right, we have the right triangle. The hypotenuse will be connecting the vertex to the outer edge down below. And we already have the distance, which we'll write at the bottom, the right triangle. Left to right from the center, that's A. Up and down, that's called B. And then, of course, this C value, the distance from the center out to the focus, that is the same C value as the hypotenuse of this right triangle. So we'll put it over here. So there are our right triangles for the two different cases. The only difference being the one hyperbola on the left opens on the right and left, while the hyperbola on the right opens up and down. Now, I want to just make a couple of comments, just as we did in our previous example, using the ellipse. The distance from the center, that's the ordered pair HK, to the focus is labeled C. So that hasn't changed. It's just like the ellipse. The distance from the center to the focus is what we call C. The vertical distance is labeled B. Just look at the sketch. When we talk about the vertical distance, we're always talking about the distance B. And the horizontal distance is going to be labeled A. Just look at the picture. Left and right, from the center, it's labeled A.